One particular aspect of Titan's atmosphere that has intrigued scientists is the observation and mapping of the appearance and disappearance of clouds. Recently, the Cassini mission has identified a cloud made of dicyanoacetylene ice, which was last observed by the Voyager mission. The mystery behind this observation is that the measured concentration of dicyanoacetylene in its gaseous form in Titan's atmosphere is much less than the amount needed in order for condensation to occur. The explanation from scientists at Caltech is that this type of molecule is present in its ice form because of ice-assisted, solid or solid-state assisted reactions. This is very similar to how clouds on Earth's poles form, once again exhibiting the similarities between the chemistry and physics of these two atmospheres. From the link below, I'm particularly fond of a quote from Dr. Michael Flaser, a distinguished NASA Goddard scientist and an expert on Titan's atmosphere. The compositions of the polar stratospheres of Titan and Earth could not differ more. It is amazing to see how well the underlying physics of both atmospheres has led to analogous cloud chemistry. These sorts of findings from observations made by space probes work in tandem with laboratory experiments and simulations to try to understand the observations and ask additional questions about chemistry and physics. While space probes are actively making measurements, such as by using different types of spectrometry, teams of scientists are trying to understand how that chemistry occurs, what it means to atmospheres, and how that might impact our understanding of chemistry and physics occurring on planets seemingly incredibly different to our own. Obviously, there are more questions than answers for the time being. An important thing to note is that Titan's atmosphere is opaque to many wavelengths of light. It wasn't until the Huygens spacecraft descended through the atmosphere and landed that we were able to get significantly more information about Titan's lower atmosphere and its surface. The last contact with the Huygens lander was in 2005. This was the first successful landing in the outer solar system, making it the first of likely many future accomplishments.